I'm very pleased to have Sathya Smith joining me today. He's a member of our TRRRA team based in Australia. Sathya, can you please tell us about yourself and your background?
Absolutely. So good morning, everyone. I hope you're having a good morning or afternoon wherever it is that you are. But my name's Sathya Smith, and I've been working with TRRRA for about 3 years now. Started back when we were called Precision Terrain Solutions, and basically started up the hardware sector of the company. Basically, I come from a background of non-agriculture, essentially. So getting into the agricultural sector, after I finished uni, I found that there was a great deal about agriculture and machinery that I was not aware of, and it greatly interests me to learn about. So basically, I found myself finding some work experience with the National Centre for Engineering and Agriculture here in Toowoomba, Australia, which is kind of linked with the University of Southern Queensland, where I got my bachelor degree from. So beyond that work experience, I basically found myself working here and been developing hardware for TRRRA ever since.
Yeah, we're glad to have you. Absolutely.
It's been lots of fun.
Yeah, good. So TRRRA Cutta and TRRRA Ditch include the Dozer application tools. TRRRA Cutta is our complete landforming package, which covers full field and drains. It does run on a tablet in cab, and in conjunction with John Deere's iGrade, it allows you to survey and design, optimize, and implement earth-moving operations. And TRRRA Ditch is our advanced in-cab ditching system, and you can survey and design terraces and drains one at a time, or you can create drains with our auto drains tool. The lines created can be exported as guidance lines for John Deere displays. So those are the two software applications that will work with our Dozer application. Right, so TRRRA Design, our desktop software, can create projects that will be implemented with the Dozer. And our in-cab software, such as chicken house projects on the left. We have users also creating design projects for implementing with the Dozer in TRRRA Cutta and TRRRA Ditch, our in-cab software. One example, for instance, would be our contour bank or terracing project seen there on the right. Sathya, you want to give us some hardware overview?
Yeah, absolutely. So just to give a quick rundown of John Deere iGrade, generally speaking. So iGrade is a RTK-based GPS system for land leveling. TRRRA software is designed essentially to interface solely with this John Deere iGrade system for automation of scraper blades and various modes for performing different types of land leveling work. So the iGrade application controller essentially provides electrical analog voltage signals to a hydraulic controller, which then performs the movement of an implement. That's important to know because the hardware we've been working on is essentially performing a bridging conversion between the application controller outputs and non-standard valves. So TRRRA software essentially provides elevation target information to this iGrade app controller, which then calculates differences in measured height versus expected height, and then adjusts the scraper to meet the requirement of whatever surface they're trying to implement. So iGrade basically consists as a whole system of one or more RTK GPS receivers, as well as an isobus display, manual controls, and then the iGrade application controller in combination with various pieces of harnessing. And there's quite a bit of harnessing involved with an iGrade setup in most cases. So move on to the next one now.
Okay.
So With regard to our Dozer implementation, we're still in very early stages in terms of applying John Deere's iGrade system to these non-standard machines. We've currently implemented the system on John Deere 700L dozer and a John Deere 850L dozer. Both of these L series dozers were very similar in terms of their implementation, and so we feel fairly confident at this point that we've worked out most of the kinks when it comes to L series dozers. But despite having worked on the L series a fair bit, we're very interested to explore different models. Cat and Komatsu are brands that have been in our eye lately. And we basically provide two pieces of hardware, which is the VM512 valve module and the SMJD DZL switching module. I won't take credit for that particular name, but essentially those two are used in unison to perform what I mentioned earlier, the bridging conversion between the application controller and non-standard valves. And in addition to that, we're currently developing some new hardware at the moment, which aims to provide an easier plug-and-play interface for trying control of Cat and Komatsu dozers as well. So that about covers for current implementations. So when we're looking at a bulldozer and trying to gauge the amount of pain that will be involved, the amount of knowledge that needs to be gathered, and the amount of patience that the customer or dealer will need to have. Basically, we're looking for information on whether there's a presence of third-party or aftermarket grade control systems. Usually, in the case of bulldozers, these would not be John Deere brand. They'd usually be something like Topcon. But it's always good to be aware of the presence of such systems, just because usually their presence indicates that interfacing will be generally easier than kind of a manual installation and conversion. So piggybacking off of that, it's nice to be aware of joystick control mechanisms, as well as physical access to connections, as well as valve control mechanisms, whichever type of electrical signals are being used to control the valves, as well as what kind of access is available to their connections as well. Machine documentation from manufacturers is ideal, but we are definitely comfortable with the idea of performing some reconnaissance and essentially figuring out what is going on with a particular bulldozer's control systems. But in most cases, that'll require a fair bit of patience. We also would be looking at remote engage mechanisms, whether there are buttons present on the console for engaging and disengaging automatic control, as well as other non-JD hardware. This could involve GPS receivers or ISOBus displays. Both of those we would need to be aware of before we could commit to anything, essentially. And then the other aspect that we don't really have the capabilities to take care of is the manufacture and supply of the GPS receiver on the blade mast for the GPS receiver. So that one needs to be taken care of through third party.
So if someone is interested in using Terra software with a dozer, these are some of the points that you would cover with them, really, if
Absolutely.
Yes, in order to help them with an installation. Okay, very good.
Mm-hmm. So from an in-cab standpoint, the hardware involved with the John Deere L-Series dozer implementation of iGrade, essentially we just had the same type of setup that you would see for any regular scraper system in the cab, which just involves a touchscreen tablet for Terra software that has some minimum requirements in terms of specifications, otherwise it won't be able to run the software correctly. And other than that, basically it just involves the use of a vehicle charger, mounting, and the connecting harness that supplies the data from Terra software to the iGrade application controller. And there are various aspects of mounting and kind of choosing the correct positions to be mounting those devices. Obviously, the operator needs a good view of everything that's going on, and many dozers do seem to have quite compact cabs, so it might be a little bit difficult to fit it in a comfortable way in some cases, but obviously that would depend on the size of the bulldozer.
Mm-hmm. Okay.
And so external to the cab, there are various pieces of control hardware harnessing, but the primary kind of pieces of the puzzle are the switching module, the valve module, and the indicator module, which essentially just provides indication to the user whether the system is in auto or manual control, as well as power. As you can see there's not really a great deal of harnessing involved, to be honest. I don't know, 6 harnesses could definitely be worse than that, but basically the installation of each of those harnesses should be, as long as it's right in an unfamiliar dozer, it should be fairly simple, given that there's good access physically. It's not a lengthy undertaking to install the hardware. And so you can see in the bottom right there's a diagram of how the hardware actually links together, just trying to point out there the different kind of harnessing positions for each.
And you might want to point out what we supply of what is listed here.
Absolutely, yeah. So everything seen in that photo there, that would be something that we would create. There's obviously going to be some different length requirements for different bulldozers. So in a prototyping situation, there would likely be some need to create your own harnessing, just because if we don't have physical access to the bulldozer, it can be difficult to measure such things, obviously. So, but our aim is to provide the entire kit once we're familiar with a particular model.
Okay.
Mm-hmm. So the actual installation and mounting of the hardware in the previous slide, that essentially there's just 2 control units that need to be mounted along with the iGrade application controller. And there's obviously going to need to be some space, either external to the cab or inside the cab. With the L series, the 850L in particular, you can see in the photo on the left there, we had a nice bit of space on the bottom left where we decided to install the iGrade application controller along with the VM512 and the switching module into those kind of beige coloured weatherproof boxes. So in this instance, we had plenty of space to mount hardware, but in some other cases, it might be necessary to either mount all of that inside the cabin as neatly as possible, or to find adequate space elsewhere if possible. And the bottom right photo there is just an example of kind of ways of getting around limited space in installations. The VM512 in that photo has been mounted with magnets, extremely strong magnets, mind you, but that essentially just provides a bit of vertical space usage instead of horizontal, so that can be very useful sometimes. So in terms of the joystick, on the L series dozer, we had quite a nice joystick setup. We were able to access the joystick connections via one of the side panels, and just kind of freely access those. And the joystick, the joystick possesses its own automatic blade control enabled disable button. So we were able to make use of that one eventually. And So the system can be engaged and disengaged using the joystick, as well as having the functionality of feeding off of the joystick's output signals in order to sense joystick movement and delatch the system in the case of joystick movement. I think that's about it for the joystick.
Okay.
Alrighty, and then the other components exterior to the dozer completely would be the GPS receiver and the blade mast. So there was a bit of tinkering involved with the blade mast on the 850L. We essentially mounted the receiver on the mast and then found that the blade was getting jolted enough to the point that the receiver was the receiver antenna was beginning to show signs of whipping, and we had some definite concerns for damage there, because everyone who's familiar with John Deere hardware knows that it's not the cheapest thing to just replace your RTK receiver. So yeah, essentially we ended up reinforcing the blade mast a little bit further, which seemed to reduce a bit of the whipping, as well as mounting the receiver on vibration isolators in order to try and mitigate it as much as possible. For going forward, I would probably think that an external antenna would be better used in this kind of situation, if the coax cable can be run elegantly down the mast. But yeah, in this prototyping situation, we basically just needed the proof of concept.
Mm-hmm.
And so I haven't gone over the theory of how the hardware actually operates at this point in much detail yet. But so basically the iGrade application controller provides 0 to 5 volt low current signal outputs, which generally would be appropriate for an SCV controller built into a machine, or some other types of control units, such as those for laser leveling. Essentially what this means is that the controller is not capable of driving a high current valve, and nor does it have the range to provide the adequate voltage signals for Danfoss style load sensing valves, or PVG valves as some people might know them. So the VM512 valve module aims to convert this 0 to 5 volt low current signal into various different output signals based on the harnessing that is created using the kit. The VM can be set up to power proportional directional valves that require PWM current control, as well as straight directional valves, and like I said, Danfoss style actuators that use a 0 to battery voltage usually, and just operate based on a percentage of that. So beyond that, the switching module switches between these newly created VM output signals and the existing signals that are present within the dozer. These might come from a existing hydraulic valve controller, or potentially there's possibilities for interfacing with the joystick outputs in other ways to provide valve power using those manual joystick outputs that already exist. But yeah, essentially the switching module will switch between those depending on the state of the engage disable button, as well as whether there has been joystick movement detected, and in that case it'll disengage the system to give the operator back manual control. So the switching module is then what connects directly to the valves and essentially provides that wire join between the two different systems. I think that about covers as much detail as I was going to go on the theory of operation. But maybe one more thing I was going to mention was in the L series dozer, those particular valves ended up requiring a PWM signal, and so the VM was used to convert the 0 to 5 volt signal into a current controlled PWM output, and then the existing controller within the bulldozer was connected to the switching module as well. So there was essentially a wire path between the VM outputs and the existing hydraulic controller.
Okay. Well, that pretty much covers the theory of operation and hardware requirements. So let's talk about the software that we offer for the Dozer application. The first thing you would need to do when you're utilizing Terracotta or TerraDitch to implement projects with a dozer is to enable the dozer mode in the dozer tab in settings. You then would enter the blade to dozer turn rotation point distance in the parameters. If you're following me, it's right here. You have the option of enabling to lift the blade when reversing. If that's enabled, you can enter the reversing lift height for that feature. The latest release of Terracotta and TerraDitch has the new feature called blade positioning. So it is right here, blade positioning, and it's in the machine tab. So it's motivated by our recent dozer experiences. It allows the operator to specify which part of the soil profile under the blade has priority in determining the blade position. It is super useful when only part of the blade is needed to perform a cut, which is often the case when you're working with banks and ditches. This option is only available when you have entered an implement width, right here, and enabled to output cross-slope commands. Once you have checked this box, you'll be able to set the cross-slope nudge increment. This specifies the incremental amount each press of the left and right tilt will add to the cross-slope. Being able to set the nudge increment allows you to decide the size of each adjustment. The cross-slope controls are in the lower left section of the map screen while you're implementing. The left and right button rotate the blade to the left and right respectively, relative to the direction of travel. As the left and right buttons are pressed, the current tilt value is displayed in the text box between the two buttons. The center button of these controls will turn automatic machine control on and off. So the slope can change under the blade from one side to the other along a bank or a feature, and this is likely to be the case when doing work with a dozer. Our blade positioning options assist users in not cutting below the design surface and getting as close as they can to it. So let's discuss each one of these options that you will have. So classic is the position that uses the design elevation as the target elevation under the center of the blade. And the cross slope is determined by the design elevations under the left and right points of the blade. With classic, it is easy to overdig when driving down the midline of ditches or to clip the top of a bank when straddling the ridge. Average. This position looks at the design surface under the blade and goes for the overall trend. This is great for taking any full field design and giving you basically that. It's not so good for abruptly changing slopes, however. And then there's average on top. This position is one step up from the trend method, literally. It determines the slope in the same way as the average method, but it allows but it always avoids overcutting. Snap fit. This position attempts to find the best blade position without overcutting. If you're going over a break line, you will see the blade snap from one position to the other as you traverse the break line. What it means, though, is that you will be cutting and filling most efficiently, minimizing the number of passes and risk of rework. And then there's the single point. This position is what everyone seems to want. It's control by point. In this configuration, you pick a position on the blade represented by the red arrow. That point on the blade will be at the design elevation and cross slope, even if it cuts below the design elsewhere. This is envisioned to be great for digging features like V-ditches. When automatic control is engaged, the cross slope nudge buttons will change to display the icon to the right. So we'll have the A for automatic control. And one final blade position option available in all situations from the implementation screen is you may set the cross slope manually. In this case, whatever cross slope you pick in the bottom left of the implement screen will be applied if you have cross slope control enabled. For the trend method, it will tilt the blade while leaving the center of the blade in the same position. For single point, it tilts the blade but keeps tracking at the control point. Snap fit and average on top adjust the blade height to avoid overcutting. Sathya, can you explain the implementation steps and your experience with it in field?
Absolutely, yeah. So for my explanation of this, it'll mainly be pertaining to the John Deere 850L that I had a bit of experience with of implementation. So that was down near somewhere called Millmerran, which is somewhat close to Toowoomba, probably about half an hour away thereabouts is how far it was. And we had a customer there interested in prototyping this system for the use of building some contour banks. He essentially just had some sloping fields where the water runoff would gain too much speed and was causing some serious erosion. So he needed to revamp some contour banks, and he was keen to have a demonstration of the 850L with terracotta in order to do that. So there were many learning steps in terms of both the hardware and the software when we were working on this particular project. In terms of hardware, getting a satisfactory kind of medium between keeping the existing dozer control systems happy, as well as providing the right kind of calibration for the use of the valves, that was a little bit tricky. There were a couple of other different aspects of I-grade that we needed to work out relating to the use of the legacy SCV outputs. So once we worked out some kind of kinks in all of that and the hardware was running correctly, it was basically a matter of just ensuring that the software was, both that the hardware was doing what the software was asking of it, and that the software was the actual design within the software was correct for what the customer wanted. It turned out that our initial design there didn't quite match up with his kind of theory of how the contour bank should look, and there was a great deal of tinkering involved by my boss Stuart in trying to create a design map that accurately reflected what the customer was actually looking for, which is always a priority. And in this case, he had a very particular cross-sectional shape of the contour bank in mind for the size of the batter, as well as the size of the not quite sure of the right term, but the scoop before the bank. So essentially once we tinkered with that, we got that to a happy level, and he was able to just create those contour banks by engaging the automatic control, lining up the bulldozer with the side of the contour bank and just doing a push. There was some need for limiting the amount of cut that was happening, because the control system would sometimes be a little bit too eager and request a depth that would get the dozer a bit stuck in clay and whatnot. So there was definitely some learning involved there as well. But once we got that to a happy point, it was just a matter of lining the dozer up, engaging the system, doing a push. Might take a few pushes to get the final shape, but at the same time, it's just as easy as driving it forward essentially and then pulling it back.
Mm-hmm. So I see that in field with other dirt moving equipment as well, just fine tuning it to what you want to achieve. So I could understand that. Getting out there and getting it just right is sometimes takes a minute. So
Yeah, definitely.
okay. Did you want to add anything else about anything about the calibrating or anything with this?
I guess one aspect to mention is that because of the use of iGrade, anyone who's familiar with iGrade would essentially have the knowledge to be able to calibrate how the valves work. It just uses the normal SCV threshold and sensitivity calibrations within the iGrade app controller menus. So that's part of the setup process, along with just ensuring that the VM512 is configured correctly too. But apart from that, yeah, that's about all I have to say on that.
Okay, very good. All right, so this pretty much covers all the hardware and software. So we're going to just say that we offer a lot of resources. This webinar, of course, will be recorded and you'll be able to view it as many times as you need to. And then we have our other social media platforms where we're always putting up tips and tricks with the software. We have reference guides. And of course, we're always available for one-on-one web training. And you can contact us and we can schedule it.